Hi folks, and welcome back to Math with Captain Rod. Making this video here is an introductory video over logarithmic functions. So what we're going to do is we're going to start by plotting y equals 2 to the x. I did that in my previous video, but we're going to go ahead and do that again right here. So as per my previous video, if I look at some x values here, if my function is y equals 2 to the x, that goes through the point negative 3 1/8. So 1, 2, 3, and 1/8 is like barely above the axis. Whoops. Gotta get into pen mode here. All right, let's see. 1, 2, 3, 1/8. All right, negative 2, 1/4. 1, 2, 1/4 is maybe a little bit higher. 0, 1. Oh, I'm sorry, negative 1, 1/2. 0, 1. 1, 2. 2, 4. 3, 8. I'm going to kind of sketch that. Okay, so there is a graph of y equals 2 to the x. All right, now what we're going to do is we're going to plot its inverse function against it. I'm going to do the inverse in a different color. I don't know, inverse functions seem kind of green to me. So remember what an inverse does. If the point like AB is on a graph, then the point BA is on a graph of the inverse. So I think I've already listed some of these points here. Here are some points that must be on the inverse. Negative 1/8, negative 3. I'm getting that from here. Oops. Just 1/8. That's not supposed to be negative. I'm sorry about that. That's just the point 1/8. Put a plus there. 1/8 minus 3. And I'm getting that from right here. 1/8 minus 3. So 1/8 minus 3. 1, 2, 3. Okay. Negative 2. If negative 2 1/4 is on this graph, then its inverse has the point 1/4 negative 2. So 1/4 is here. Negative 2 is just down below a little bit. Did that point disappear on me? The one that was about here. Okay. Right. Now negative 1 1/2 is on this graph, so the point 1/2 negative 1 is on the inverse. So 1/2 negative 1. 0, 1 is on F, so 1, 0 is on the inverse. 1, 2 is on F, so 2, 1 is on the inverse. 2, 4 is on F, so 4, 2 is on the inverse. 1, 2, 3, 4, 1, 2. And that's probably enough. I'm just going to sketch this in now. So hopefully we remember I made a video about graphing a function against its inverse, and one of the things about the video, hopefully we remember, is that when you graph a function against its inverse, the graphs are symmetric about y equals x. And if you look at this, right, you notice that this green graph is a reflection about that line, y equals x. All right, now let's talk domain and ranges. You'll notice that this function here there's nothing over here, okay? So the domain of this function is x greater than 0, strictly greater than 0. And I'll talk about why that is here in a minute. Range, now we're looking at y values. So you'll notice y 0 is on there, y equals plus 1, plus 2, and it just keeps going this way forever. You'll notice that negative 1 is on there, and negative 2, negative 10, negative 1,000. So the range of the inverse here is all real numbers. Now, look at the original function. See how the domain and ranges are switched? The original function had a domain of all real numbers, and a range y had to be greater than 0. The inverse has a domain of x greater than 0, and a range of all real numbers. And this is hopefully fairly natural to understand, because remember what an inverse does. If the point AB is on a graph of the function, then BA is on a graph of the inverse. So let's talk about the inverse of y equals 2 to the x, and if we wanted to find it. So remember how we find inverses. We switch the x and y values. So we get x equals 2 to the y. Now, the solution of this equation is what's referred to as a logarithmic function. Right? This is written, the solution of this is y equals, y equals log base 2 of x. And this is this function right here. So what a logarithmic function is it is the solution of this exponential equation. It's an example, it's called a transcendental function, and I'll make other videos about what transcendental functions are. So this is what a logarithm is, or a logarithmic function. It's the solution of an exponential equation. Right? And this function is the inverse of y equals 2 to the x. Right? So a logarithmic function is the inverse of an exponential, and it's the solution of this equation here. So that's my best description, I think, for now for what a logarithmic function is. You'll notice here that the domain is all real numbers. Right? These two things are basically equivalent to one another, and I'll make other videos about how you go back and forth between exponential form and logarithmic form. But when you take a look at this, right, notice there is no value of y that you can take 2 to a power and get a negative number. Right? So this thing right here does not have any negative values of x. That's why the domain is x greater than 0. Also, if I put a 0 here, there's no value of y that'll even get you a solution to that thing. So that's why our domain is greater than or greater than 0, strictly greater than, because if you put a 0 here, there's no value of y that actually gives you a 0 out of that. Let's see, range. You'll notice you can put anything into this you want for y, and you're going to get a number out here. For x, you'll get some value, and that's why, again, the range is all real numbers. So, long story short again, what is a logarithm, right? Well, it's the solution of this equation, and this equation represents the inverse of this function, of an exponential function. So a logarithm is an inverse of an exponential function. That's what it is. Logarithms have a base. In this case, the base is 2, and I'll just make a separate video about logarithms and bases and things like that. So this was just meant to be an introductory video about logarithms. I hope that it's helped with that for you. Have a great day.